The segment addition postulate states that if a point L is between two other points, K and M, then the sum of KL plus LM is equal to the entire length of KM. This is easier to understand by checking out this diagram. Here we've got a point, L, and it's definitely between the other 2 points, K and M. And if I want to examine this postulate, well, I could take the length of KM by finding the absolute value of 8 minus 17. I see that that's equal to 9. And now I'm going to compare it to the lengths of these segments right here, KL and LM. I see that KL has length equal to 2, and I see that LM has length equal to 7. When I sum those up, what I get is equal to 9. The other part of this postulate states that, and it's right here, it states that if we have that relationship, if we have that KL plus LM equals KM, then we know that the point L is between those 2 points, K and M. That is to say that we know those points are collinear, which is another way of saying that the 3 points are all on a straight line together. We can use this postulate to answer some pretty interesting questions, and here's an example of one. It states that if the points R, S, and T are collinear, so that means they're all on the same line, and if S is between R and T. Well, that was the other part of the segment addition postulate. And what we're going to do here is we're going to find the length of RS, but I want you to notice that RT and ST, well, their lengths are given in terms of expressions with an unknown variable. We can still use the segment addition postulate. Look at this. We have RT, and its length is right here. It's 5x plus 1. And we are actually told that the length of ST is equal to 2x minus 3. We can write that kind of over on the side. So what we need to do is find the length of this portion, RS, and what we can do to find it is subtract these 2 expressions. So that means that I'm going to go like this. I'm going to take that 5x plus 1 and subtract 2x minus 3. When I do that, what I end up with is, well, I'll combine like terms, and I see that I have 3x minus, or rather plus 4, and that is in fact the length of RS. So now you should practice a problem like this on your own. Adjacent angles are formed by 2 angles that share a common vertex and also have a ray in common. So on this diagram right here, I can see 2 angles, angles JHK and angle KHG, and they share a common vertex H, and they also share a common ray, HK. So they are adjacent angles. Let's clear away those markings, because I want to point out to you that these 2 adjacent angles form a larger angle, angle JHG. And in fact, we can talk about the measure of that angle by using the angle addition postulate. This is very similar to the segment addition postulate, because it states that the measure of an angle created by 2 or more adjacent angles is equal to the sum of the measures of the individual angles. On this diagram, I see that angle JHK and angle KHG come together to form angle JHG. So I know that the sum of the measures of the adjacent angles is equal to the measure of the larger angle. In fact, since JHK has measure equal to 22 degrees and angle KHG has measure equal to 130 degrees, I know that the measure of the larger angle JHG is equal to 22 plus 130, which is 152 degrees. Next, let's see, though, what we can do when we're given a more challenging problem. Here we have 3 adjacent angles, and each of their measures is given by an expression. We're furthermore told the measure of the outside angle, angle AED. And then we're asked to find the measure of the smallest angle in the diagram. Well, if I sum together all of the expressions for the inside angles, the adjacent angles, I end up with an expression that represents the measure of angle AED. And I can use the fact that AED is given to us as 132 degrees to set up an equation with that expression. And next, what I'll do is solve for x. When I solve for x, the first thing to do is combine like terms. I see that I have 10x plus 12 is equal to 132. Next, what I can do is subtract 12 from both sides by using the subtraction property of equality, and that gives me that 10x is equal to 120. Finally, I will divide both sides by 10, and that tells me that x equals 12. Our final step for this is to plug or substitute x into each of those expressions. So 3 times 12 plus 4 is equal to 36 plus 4 is 40 degrees. 5x, that gives me 60 degrees. 5 times 12. And then finally, I need to go 2 times 12, that's 24 degrees, plus 8 more, that is 32 degrees. So I see that the very smallest angle is angle BED. As a quick check, we can actually add up those three angle measures. So when I go 40 degrees plus 60 degrees plus 32 degrees, I get the result is equal to 132 degrees, exactly like we'd expect.